I am Suzanne LaGrande, and this is the Imaginary Possible, a podcast about the captivating potentials and the troubling realities of artificial intelligence. Today, my guest is Leila Kaneda, who is a machine learning engineer and customer success representative at Voxel 51. She is also a musician, a baker, and an outdoor enthusiast who lives in Hood River. Welcome.
Thank you. It's an honor to be here.
Could you talk a little bit about your journey and how you got into machine learning?
When it comes to how someone actually becomes a machine learning engineer, it's kind of funny because it's not like you get a degree in machine learning. That doesn't exist. But machine learning is across so many different types of domains that you usually get a specialty. So for me, I have a computer science degree with a specialty in machine learning. There are other folks who will have a mathematics degree with a specialty in machine learning, or a physics degree with a specialty in machine learning, and each come with their own set of different types of education. It's one of those things that's just so quickly moving that you can get it pretty much from a variety of different STEM domains. But for me, how I kind of got in the field was when I was originally doing music. I got to a point in my career where I realized that I needed to make a choice. The career that I wanted for music was not going to align with like my personal goals and my professional goals. I couldn't have both. So I decided that I wanted to find something else that would allow me to keep doing music professionally, but on my own terms. And so when I was looking for what that something else would be, I explored computer science, mainly because I came from, a family and a group of friends that were all in that field. It felt natural. I had a math degree, it seemed, easy enough to get started. There was a great program where I went in. And then as I did that, within my first 9 months, I had to choose which direction I was going to go. And machine learning very quickly for me became one of interest.
And what attracted you to that field in particular?
So, machine learning in its simplest form, you can think of it as a series of algorithms, just like computers run on algorithms, but these are all ones that we would call non-deterministic. They're probabilistic. So it's not like you program a set of rules and they always follow those rules. Instead, they're going to learn what they should be doing given data or given other parameters that you tune along the way. And that's where the probabilistic statistical side of things comes in. And so when we think about what is machine learning, it's all these algorithms we can train to learn off of pieces of data that we give it to then make decisions based off what that data is. And it could be as simple as a classifier, which is, you give it some kind of input and it tells you what it is on the output. Like, one of the famous ones is you see in the news, you have chihuahuas versus muffins, and you're trying to feed it in to decide if the picture is a chihuahua or a muffin. So, it's just like very basic, but they can also get much more complicated, like being able to predict time series or, where we are today with generative AI, where you're being able to generate things out of what seems like out of nothing. But in reality, it's been trained to develop those different network connections to know like, hey, if I give it these words, I know how to generate whatever you're looking for. But at the end of the day, it's really just comes down to all of what is machine learning. And it's really just that ability to learn, like the algorithm to learn what it should be doing based off of the data it's been trained on. And for me, the reason I found this interesting and why I really fell in love with it was because of the way that you have to think about problems. So, like I mentioned before, my degree is in computer science, but I actually don't like coding, and which is kind of funny as a computer science person. What I really fell in love with is machine learning. Is it's not the emphasis on writing code; it's the emphasis on the scientific method, on figuring out like what is going on with my data, what story is it telling me, and how can I use that to teach my model what it needs to know, because at the end of the day, everything that's output is a result of everything that was input.
I know that machines are really good at solving closed-ended problems where there's a set outcome, like a calculator. And humans are particularly good at open-ended questions. Why is it that we are training machines to do what we are actually really good at ourselves? And why would we trust a machine's speculation on an answer versus a human?
That is a fantastic question. And really, what we're trying to do with machine learning is not replace what humans are trying to do. We're trying to utilize its strengths to find ways that it can help humans instead. So, for example, like the classifier, you don't need a human to sit in front of something and tell, like, is it, A or B, or is it like one of these 10 different things, But then when you think about that in terms of what that frees up a human to do, it allows them to do that, those more complex ways of thinking, like philosophical thinking, the arts, the creativity, much more complex problem solving, dealing with other humans. And so, what we're finding out is, well, yes, sometimes you hear about these bigger advancements in AI that are like appearing to like think for themselves or stuff like that. Really, the practical AI, the stuff that's really being used by people every day, is to try to take those monotonous tasks that we have to do and free us of that so that we're now able to do the things that we're better at and the things that we have more of that creative mind space for, which is the philosophical thinking, the STEM jobs, the arts, the teaching, right? All of those different kinds of things. And an example of that is like using AI in manufacturing. So, if you're going through and you have a pipeline and you want to make sure that there's no defects in something. And if there's a defect, you move it to the side, right? You can have someone staring at that for hours, but not only is their brain going to get tired, like it's really hard to look for the same things over and over. It's like very draining. And instead, you could just have an algorithm look at it really fast, and just be like, yes or no, yes or no. It's more to like to make those jobs that like we don't want to do, or maybe we could be using our time wisely doing other things, and to help aid us. Or even like in the creative process, we have things like ChatGPT. Right? That's another generative AI algorithm that people are like, wow, it can do so many things. But if you think about how it's really starting to be used and played, it's like for writers, for example, it's giving them ideas to help unblock them from writer's block. With coders, it's helping them write boilerplate code that they would otherwise have to like go search on Google for because it's maybe using a library they've never used before. Or maybe it's helping scientists, look for research papers instead of having to search Google. They can now ask GPT direct questions and be able to get answers. And so I feel like that's also a really prime example of how machine learning is here to help rather than replace. And that's to make it so that we can do so much more.
What I'm noticing when people describe, for example, having an AI personal assistant or a coach or I've heard even like cognitive coach, right? Somebody who's generating ideas. It seems like we're moving into the realm of not just gathering information or automating repetitive tasks, but making decisions and helping humans make decisions about things that are really important. Is there a danger in having machines take on those more substantive roles of helping us make decisions that involve our lives, but also potentially the lives of other people?
So I wouldn't say that there's a danger in the sense that the machine is dangerous. I would say the danger exists with the person using it because at the end of the day, what it's doing and everything that it's producing is just the output of an algorithm, right? So where it really comes down to is how the person who is using it is taking that output. And so, if you're using it to help make these decisions, to have these conversations, to have this assistant, if you're doing it without any checks, like you're not checking its reliability, you're not making sure that everything it says is accurate. If you're not doing those things, then it becomes dangerous because you can't blindly trust any machine learning algorithm. That's like one of the very basic rules, right? Like these things aren't perfect. They are learned and we keep improving them, but there will always be issues, at least with how technology is today. Nothing is perfect. And so if you're blindly trusting these algorithms, then yeah, you're in danger if you're making very important decisions based off of what it says. However, if you are smart about it, and this is where education really comes in, and you learn how to interact with these things and not just blindly use whatever comes out, then there really is no danger there.
I've heard that some people have almost completely switched from Google searches to Chat GPT rather. How could we check this information? Because Chat GPT, for example, doesn't tell us where the sources of information come from. So, how do we know if this is legitimate, credible information or stuff that ChatGPT may be making up or hallucinating, which it sometimes does?
Yeah, and really what that comes down to is the same methods that we used before ChatGPT. Checking your sources, figuring out where things are coming from, maybe like doing a search on something that seems suspicious. It really also depends too on what you're using GPT for. Like if you're using it to write a letter, then maybe you're just checking if the letter makes sense and it's saying what your intent is, and that's enough validation. If you're using it to write code, maybe you run the code and see if it works or see if it doesn't. If you're asking it more of these like technical questions, take the answers that it says and go check them against in a Google search, maybe, or a Google Scholar search, and see if you can find the paper to back it up. Or ask GPT, what is the paper to back it up? And then it will give you the source, and then you can go check that source and see if it's legitimate or not.
A lot of people are terrified, nervous, also enthusiastic about AI and its possibilities. Can you help us to sort out what things are perhaps misconceptions about AI that probably are not true, and what things maybe we should be a little bit concerned about?
In general, when people are concerned or just afraid of what AI is, it usually comes down to not understanding what AI does. So one of the big things we hear is, oh, AI is going to take over the world, or AI is stealing all of my data and it's using it to do things I don't want to do, or who knows what else, right? Like it's following me, tracking me, all of these things that we're using AI online. And yes, some AI algorithms are meant to track or are meant to classify, right? There's a variety of algorithms and it comes down to the user. But the biggest, I think, myths here are that AI is smart enough to do its own thing. And that is, at least with today's limitations and technologies, 100% false. Even if it seems like that it is doing its own thing, like ChatGPT is thinking for itself. It's not really thinking for itself. It's every algorithm is limited by the data that goes in and the human that puts the data in. It can only be as good as that. It's not essentially learning these things on its own. And for me, when I first learned about stable diffusion recently, that's like Dolly and kind of what came right before ChatGPT. Um, at first I was like, wow, this is literally like coming out of thin air. What is going on? And then when I finally learned about what the algorithm was doing, I was like, oh, it works just like everything else does. Takes data in, outputs data, and then once we're using it, it like just learned whatever path it was supposed to go down. And therefore, like the black box was unveiled, and it was like, okay, yeah, it's just acting like everything else, but it looks shiny because it's being used in such a new, like fantastic and generative way. They won't take over the world anytime soon. It's always in, data out type of relationship.
What should we be concerned about with respect to AI development?
The biggest things are what the algorithms are that you're using, and trying to find out where their data sources are coming from. If you're using, facial recognition or something like on Zoom with blurring a background, identifying a face. If you're worried about anything, go see where their data sources come from, or if they publish them, or reach out and ask. ChatGPT got its source from the internet. What does that mean, right? Like, is it the whole internet, the internet plus a section of the internet? Because what you take defines your bias. And there's no caution sign as much as just an awareness sign, like understanding that, things might have gaps, and by identifying those gaps, we can improve them.
Given that a lot of times we don't know where things come from, what are the dangers in that? For example, with respect to bias.
The danger comes from not being aware, not paying attention, or really the same things that we face when we're thinking about the dangers in day to day, right? Like when people say, check yourself or understand where you're coming from, right? We hear those phrases a lot. Those types of things can also apply to AI. Like the danger comes from turning a blind eye, trusting them blindly, following them blindly, And so unveiling the black box for yourself at whatever level that means to you is probably the most important part. So that way, when you're using these technologies, you feel comfortable in making the decision to use them or not use them rather than blindly use them.
You are listening to The Imaginary Possible, a show about the captivating potentials and the troubling realities of artificial intelligence today. I'm your host, Suzanne LaGrande, and this is KBOO Community Radio, KBOO 90.7 FM in Portland. You know, a lot of people are concerned about the issue of data bias or algorithmic bias. Can you talk a little bit about what that is and what causes it?
Yes. So data bias and model bias comes from the problem that a algorithm has been trained on something that is biased. The same way we think about bias in the real world. So if I have a model that's biased, it means it's likely favoring something over something else. Something that's very tangible. An example of this would be if you have a facial recognition algorithm that is favoring a certain skin tone. Or when we talk about audio recognition, like talking to Siri or talking to Google, it's recognizing a certain voice frequency that's caused by bias in the data sets. Usually we try to combat these things by doing checks to make sure that our data sets are balanced and representative of everything that we want to think of. But when it comes to what is data bias and what is it doing, your models become biased from the data that you pass in. So it becomes from having to observe what you have and having to apply that to what you need. So the ways that we combat this are by looking at our data and understanding what's in there, and then training our models and understanding how they react based off the data we fed in to find the loopholes that we're not able to see. And it becomes this constant iterative process of improving our data sets until we finally feel like we've gotten to a point where there's enough of a check, in which case we feel confident to put it in the world, get more data, and then continue refining. And so when we're talking about model bias, it's about the data bias itself that comes in.
You advocate for developing tech communities that are inclusive and include women and underrepresented groups in the tech space. You've worked with Portland State's We in Computer Science and also the Gorge Technology Alliance's Women in STEM programs. Could you talk a little bit about the work that you've done with these programs and why you think it's important to create more inclusive tech spaces?
So both of these programs, I had very similar types of work that needed to be done, helping those groups just naturally and organically grow. But nothing was really happening. And by trying to lay foundations by taking on just one part of it, the mentorship program, I decided to take that on with someone else. We were able to lay enough foundations to spread awareness about the group, bring in new people that were energized to meet one another and speak up, and form this community that then just started having this effect of permeating through the rest of the department, creating awareness through the rest of the department, and creating excitement through the rest of the department. And by doing that, it got a lot more awareness of what some of these problems were that we were facing throughout the years past when I was there, but also just getting people excited to talk to each other, be in the same room as each other, have opportunities that they wouldn't normally have otherwise, have people that they feel like will help them get through the program. A lot of people don't realize this, but the Gorge itself has a pretty big technology space, especially in the drone industry and aeronautical industry. But although we are, maybe 60 minutes away from Portland, there is still that disconnect. So being able to connect people in the Gorge, but also some semi connect them to Portland too, so that they have an even bigger community, as part of like what we were able to do with that group. Like building community and trying to find these people together is really important, because being a minority in any space is difficult. Being a minority in the tech space is uniquely challenging because there is no rhetoric around it, and there is no conversation ability to find the people to talk to that can relate to you. Everyone has a different experience in a different sector, even like within machine learning, jumping from the aeronautical industry to the semiconductor industry to just like the general computer vision has been a drastically different experience in each space, just being a woman. And so the power of having a community of people from all different walks of life and experiences to learn from is really, really important. And finding that community is really challenging. And so that's where these efforts for community building come into play. And this is actually something that I learned and saw from my time in music. And it became, why was music so good at this part and technology is so bad at it? It always came down to community. And so really drawing that mind together, learning the strengths of community building that music has and mirroring that and bringing it to the tech space has a really big impact of unifying that stuff.
Talk briefly about what some of the problems or patterns you see in various tech spaces are with respect to inclusivity?
This is a little bit of a touchy subject for some people, so fair warning. But some of the things that we see are just, depending on the industry, they can be very blatant. I've had experiences where I'm working in a trade show and have people like I'm supposed to wear what everyone else is wearing, right? Maybe like a t-shirt and nice pants or something. And not getting respected, like at a booth, like completely getting ignored or having comments made about what I wear when I'm working in, uniform compared to like male colleagues or compared to other people. So then there becomes this need to overdress, right? And change what you're wearing to be able to get enough of a respect to talk to someone. But then that also backfires on you because now they're like, oh, look at how you're dressed, or like you are in making comments. So sometimes it can be like that, which is unfortunate. Other times it can just be with how people are interacting with you, the things that they say or the things that they choose not to say, being more indirect. Sometimes it can just be the culture. So, like, if you're the only woman in a room, it can very easily be difficult to fit in. Like, bro culture sometimes comes up, right? That ability of like, it's just a different language. It's really hard to explain. But being the only woman in a room versus being two or three women in a room is actually a really big difference in helping that and giving each other the space to speak. Salary also comes into play too, not necessarily talking about equity of numbers, but just ability to talk about it, the ability to advocate for yourself. Especially when it comes to promotion, when it comes to confidence, it comes up a lot. Um, as well as like just small benefits. Like when you start looking at your benefits package, do you get maternity leave, right? Like we sometimes take that for granted in Oregon, especially now that it's, I think, a law that you have to provide something. But I've worked for companies or been interviewed for companies that don't give you that don't allow that. So sometimes it comes through that way too, or even just how people are talking, interacting, or understanding.
You mentioned what you learned from being in music and playing music at a professional level. And you also are now a baker as well. Both of these activities are very embodied, real world activities. And we think of AI and machine learning as being very disembodied, computer based, technological. Do you see a connection between those two?
I think there is, and this is what kind of makes it beautiful, which is being in software development, not just AI, but software in general, is seen as a very like technical thing. And it's technical, but it's actually more artistic than a lot of people realize. Like you can solve a problem, but the way you solve a problem, especially a complex problem, maybe one that hasn't been solved yet, um, it requires a lot of creativity in how you want to design it, how you want to function it, and then working with other people to continue evolving the design. But how are we going to do that? That question of how, like, what's the data that we need? What is the structure of the data? What do I know? What do I not know? What questions can I ask? All of those things are extremely creative. They're not black and white answers. The only black and white thing is our like high level template of, okay, we want to make a model. Here's the steps we need to take to make a model. Everything else relies on the person and the creativity of the person. And so if you take that and translate it to baking or music, or even just like being out in nature, for me, like those are very highly tangible creative things. But even for me, like with music, there is a part of it that is just technical. It's not creative, right? Like every time I'm learning a new piece, the music's on the page, the metronome's on my music stand, and it's just like, okay, we got to learn these things, right? It's like just learn it, and then after that, that's when the music really starts to come out, understanding the chord structures, how the music should be phrased, how do I want to phrase the music versus how does it say it is on the page? Is the composer alive? If they're alive, am I working with them? Am I not working with them? Is this a new piece being premiered where I am essentially the voice of everything that is right, or are there recordings to look at? And so music actually becomes more technical than you think it is. And technical work is actually much more creative than you think it is. So that overlap is actually much larger than you might think, and they play into one another really nicely.
Today on The Imaginary Possible, I've been speaking with Leila Kaneda, who is a machine learning engineer and customer success representative at Voxel 51. She's also a professional musician and a baker and an outdoor enthusiast. If people want to find out more about the work that you do, where can they go?
So there's two avenues. If you want to follow what I'm doing at Voxel 51, you can find us online, on LinkedIn, on our website, social media. I believe we're on Twitter as well. So Medium, and you can find us. We're always putting out content, hosting events, webinars, everything you want in the computer vision space. If you want to follow me more closely, you can find me on LinkedIn right now. That's the best way. I'm in the process of creating a website, which will be accessible via there soon. So you can also check out my website when it launches. And if you want to get in touch, you can always send me an email, leila.kaneda@gmail.com.
Thank you so much for being on The Imaginary Possible today.
Yeah, thank you. It's my pleasure.
You're listening to The Imaginary Possible, a show about the captivating potentials and troubling realities of artificial intelligence today. I'm Suzanne LaGrande, and this is KBOO Community Radio, KBOO 90.7 FM in Portland. To listen to this and other episodes of The Imaginary Possible, visit us online at kboo.fm or theimaginarypossible.com. Thanks so much for listening.